Compound inequalities. A compound inequality is a sentence with two inequality statements connected either by the word and or by the word or. When two inequalities are joined by and, the compound inequality is called a conjunction. And indicates that both statements of the compound sentence must be true at the same time for the compound statement to be true. The solution set is the overlap or intersection of the solution sets for the individual statements. So we'll look at example 1. So the compound inequality here is x is greater than 1 and x is less than or equal to 4. First, we're going to do each part of the compound inequality, and then we'll put them together. So if we set it up with, let's set up 0 right there. There's 5. These should be about the same. All right, so on the first one, x is greater than 1. So there is no equality there, so it's going to be an open circle. The open circle will be at 1, and x is greater than 1, which means it's going to be shaded that direction. On the next one, x is less than or equal to 4. And since there's an equal sign here included, we have a closed circle at 4. And x is less than or equal to 4, which means it goes this way, and it goes on forever that way. Now you can see that if we take the first one here, and we move it down below, and we take this one and we move it down below, what we're going to have is a situation where we have an open circle here at 1, we have a closed circle at 4, and the place where these two things overlap is going to be, let's see, what color makes sense here? I don't know, maybe some kind of weird brown or something is going to be all this in here. So the actual solution looks like that. So you can see it's this portion right there, or similarly, this portion right there. So it's the overlap of the two parts of the compound. A conjunction can always be represented in, in a single or in a combined or in one statement. Yeah, I think in one. And the way that we can do that, this is only for conjunctions. So we could rewrite this part right here, x is greater than 1, as 1 is less than x. So these two things mean the same thing, but then it allows us to add this part on right there, because then x is less than or equal to 4. So this is like one single statement that says the same thing as that. And that will always work for a conjunction. When two inequalities are joined by or, the compound inequality is called a disjunction. And indicates that as long as one statement is true, so one of the two statements is true, the entire compound sentence is true. And so let's look at example 3. So this is similar to that last one, a little different. So again, we're going to set up our situation here where we have 0, 5, and these could continue on. It doesn't really make any difference. They should be spaced apart about the same. All right, so first, x is less than or equal to 1. So x is less than or equal to 1. So it's going to be a filled-in circle going this direction. Next, we have x is greater than 4. So it's an open circle because there's no equality included there. And then x is greater than 4, which means we're going this way. And now when we take those two together, right here, so now it's this putting them two together, so it's just going to be like this. And what you should notice about this situation is that there is no way for these two things to be true at the same time. This couldn't be true and also have this be true. They're not overlapping anywhere. So that's why the disjunction, the entire compound statement, is true if either this is true or this is true. And we can put them on a single graph like that. So solving compound inequalities is a lot like solving standard inequalities, especially if you break the compound apart. So here we're going to look at example 4. Hopefully I have enough room here to do this. I'm not sure that I'm going to. So here is a compound inequality. It's a disjunction. But we're just going to solve each part. Whoops. 5x minus 7 is less than 13. I'm going to add 7 to both sides. So I get 5x is less than 20. Now divide by 5, and the result is x is less than 4. The next part is going to be negative 4x plus 3 is greater than 11. Subtracting 3 from both sides, we have negative 4x is less than 8. Divide by negative 4. Now when we do that, it's important that we switch the sign because we're dividing by a negative. So it's less than negative 2. So now if we're going to graph this, the important points that we would want on here are negative 2 and positive 4. Doesn't really matter anything else. But what we can say is x is less than 4. Did I mess up somewhere? Let's see. The reason I'm wondering is because it looks like they're going to overlap some. And this actually can happen. I'm just surprised. I was surprised that I made this as an example. X is less than 4. It's going to look like this. Whoops. It's going to look like this. That way. And x is less than 2 is going to look like this. That way. So if either one of those things is true, then the compound is true. So really, if x is less than 4, then it's true. Now sometimes, often they'll face out this way, but they don't have to always. All right, on the next one, we're going to break this apart into 2 as well. So we'll start with negative 12 is less than or equal to 7x plus 9. And I'm going to subtract 9 from both sides to get negative 21 is less than or equal to 7x. Then dividing by 7, I will get negative 3 is less than or equal to x. So I did this part right here. And now I'm going to do this part right here. And so we can do 7x plus 9 is less than 16. Subtracting 9 from both sides, we get 7x is less than 7. Divide both sides by 7, and we get x is less than 7. So now we're going to graph both of those things on the same set of axes, on the same number line. And we want -3 and 7. So x is less than or equal to -3 is less than or equal to x. So that means that we're going to go filled in circle, going this way, but also x is less than 7, so it's going this way. So all of this in here is our solution. So really remember that the orange would continue on this way forever like that, and the blue would continue on this way forever like that. But because we have a compound inequality, that's where it stops. And that is compound inequalities.